Hello, everyone. In today's video, I will be talking about data types. Data types in R are an essential aspect of understanding how to work with and manipulate data in R. In this tutorial, we will explore the different data types available in R and learn how to work with them effectively. R is a versatile programming language that supports several data types, including numeric, character, logical, integer, and raw. These data types allow us to store different kinds of information and perform various operations on them. Let's explore the numeric data type, which encompasses all real numbers. For instance, consider a variable named x that we assign the value of 5. To successfully run using your keyboard, please hold down the Control key while pressing Enter. This will initiate the execution process. Once we execute the line, we can observe that x appears in the global environment with its value of 5. This indicates that the line ran successfully, as confirmed by the console output. To identify the specific data type of our variable, we can utilize the built-in function class. When we check the class of x, we will see that it is classified as numeric. This approach allows us to gain a clearer understanding of how different data types are defined and managed within our coding environment. Let's do another example. Let's consider the variable name y and assign it a value of 3. When we execute this, we can see that it runs successfully. To determine the data type of y, we can use the class function. Upon doing so, we find that the data type of our variable y is numeric, which confirms our assignment. When working with numeric data types, we can perform various arithmetic operations such as addition, subtraction, multiplication, and division on numeric values. For instance, if we add x and y, where x equals 5 and y equals 3, the result is 8. Before we continue, I would like to establish a title. Okay, now let's look at subtraction. If we subtract y from x, the result is 2, as shown in the console. In the case of division, dividing x by y yields approximately 1.66. Additionally, we can explore exponentiation, where x raised to the power of y will also be reflected in the console. Feel free to experiment with this calculation on your own to deepen your understanding and improve your skills. Let's explore character data types in R. The character data type is specifically designed to represent text, and it is typically enclosed in either single or double quotes. For instance, we can assign the name John to a variable called m like this. In the same way, we can assign the name Janet to another variable named f. To determine the data types of these variables, we can utilize the class function. By executing the following commands: class m, this will return character. When it comes to the second variable, you can see that class F, this will also return character. We can see that both M and F are recognized as character data types. It's important to remember that any text enclosed in quotes, whether single or double, is interpreted as a character data type. For example, if we create a new variable named C and assign the value 15 to it within double quotes, when we check the data type of variable C using class C, this will return character. We can confirm that C is also classified as a character data type since 15 is enclosed in quotes. This demonstrates how R consistently treats text as character data, regardless of whether the text represents numbers or letters. Logical data type. The logical data type in R represents Boolean values, namely true and false. It is useful for making logical comparisons and conditional statements. To enhance our understanding, let's create a new variable named W and assign it the value true. When we check the data type using the class function, we will observe that it is categorized as a logical data type, as indicated in the console. Next, let's explore another example by assigning false to a variable called D. Upon checking its data type, we will find that it is also classified as a logical data type. This reinforces the concept of logical values in our programming environment. In our previous examples, we established that the variable x is set to 5 and the variable y is set to 3. Now, let's use these values to explore some comparisons. This will help us deepen our understanding of how these numbers relate to one another. To make things clearer and more enjoyable, let's put a title. For instance, we can start by determining whether x is greater than y. This comparison will result to true, confirming that 5 is greater than 3. Next, we can investigate if x is less than y. You can see that the result is false as displayed in the console. Finally, we can also try another example by checking if the summation of both x and y is greater than 25. The result is false. By working through these comparisons, we can gain valuable insights into the relationships between these variables. Consider taking the initiative to explore using different variables on your own. This approach can deepen your understanding and enhance your learning experience. The next data type we will explore is the integer data type. In R, the integer data type is used to represent whole numbers without any decimal places, making it a valuable tool for various numerical operations and calculations. Understanding how to utilize this data type effectively can enhance your data manipulation skills in R. Let's create a new variable named s and assign it the value of 20. To ensure that this value is recognized as an integer data type in R, we should append an uppercase L to the number, like this, 20L. Afterward, we can check the class of our variable s by using the class function. This will confirm that s is classified as an integer, which will be displayed in the console. If you're uncertain about the data types you are working with in R, there are several built-in functions that can help clarify this. For instance, to determine if a variable is of character type, you can use the is.character function. This approach will enable you to better understand your data and ensure that you are applying the correct methods and functions. When we apply this function to our variable x, we observe that the result is false. This is an important insight, as it highlights that the value of x is 5, which is a numeric data type rather than a character data type. When you use the is.numeric function to check if our variable x is numeric, the console will return true. This can help confirm that the data type is correct for further analysis. Understanding this distinction can help us better troubleshoot and refine our code moving forward. To determine if the variable m is of the logical data type, we can utilize the is.logical function. This will allow us to check the data type effectively. Here's how you can perform the check and display the result in the console. Feel free to experiment with this function to enhance your understanding and discover additional functions that we didn't cover in this tutorial. Thank you for watching. If you found this video beneficial, please consider giving it a thumbs up and subscribing to our channel. Your support helps us create more informative content for you.